Brace yourself, the latest findings on 3I Atlas will blow your mind. We've got a major update, our biggest yet, on the most intriguing interstellar visitor. It might be the story of the year in the solar system. Watch this. Astronomers have just captured fresh images of this enigmatic object right after perihelion. What those frames reveal has stunned the community, and it gets better. China has just published a new close-range shot of 3I Atlas. This release is causing a frenzy among researchers because it's among the nearest in-situ observations of an interstellar comet by a spacecraft to date. In today's video, we'll unpack everything: what the new imagery actually shows, what China's space team disclosed, and why these results left experts speechless. Most importantly, we'll dig into surface data that's forcing scientists to ask a huge question: is 3I Atlas a natural comet or something else entirely? This frame was captured on November 5, 2025 by the Raves Observatory. At first glance, it looks like a soft, fuzzy glow suspended in space. The sun lies toward the bottom left of the scene. But that's not what grabbed attention. The real surprise is a tight, compact core of light with no obvious comet tail at all. Normally, comets sprout long, glowing dust and gas tails near the sun. But 3I Atlas appears to be missing one. Stranger still, the coma, the gas and dust envelope around the nucleus, looks nearly identical to Hubble's July 21 image. In short, very little seems to have changed, even after the solar close pass. That's what floored scientists, because nobody expected it. Here's the context. As 3I Atlas swept close to the sun, it began acting oddly. Its brightness spiked to about magnitude 9, blowing past earlier forecasts. That sudden flare left astronomers wondering what was really going on. Adding to the puzzle, teams confirmed a small but real non-gravitational acceleration, meaning the object sped up in a way gravity alone can't account for. The cause of that extra push remains unclear. Harvard astrophysicist Avi Loeb floated one plausible idea. 3I Atlas may have shed a measurable fraction of its mass, material venting from its surface, creating a rocket-like kick as escaping gas pushed in the opposite direction. By his estimate, if it's a natural comet, it would have jettisoned around 13% of its mass near perihelion. Building on that, Loeb made a clear prediction. After it emerges from solar conjunction, within a week or two, if it's a normal comet, we should see a huge, brilliant cloud of gas, possibly an intensely bright tail. If we don't, then what caused the boost? There's no easy way around that. But when teams examined the post-perihelion imagery, the expected cloud wasn't there. In fact, 3I Atlas looked much as it did before solar approach. No obvious tail, no dense gaseous shroud, no clear signs of massive mass loss. So the big question, if 3I Atlas really shed that much material near the sun, where did it go? And if it didn't, what produced the odd acceleration and sudden brightening? One more twist. Observers report 3I Atlas has shifted color for the third time, now showing a bluish halo, highly unusual. Taken together, the missing tail, stable-looking coma, unexplained non-gravitational push, and color change, 3I Atlas is fast becoming one of the most perplexing interstellar objects ever studied. Solar system comets flaunt gorgeous anti-sunward tails. Lemon is a great example. But in 3I Atlas's case, it still presents as a diffuse ball even after perihelion, despite heating at 770 watts per meter squared. Professor Avi Loeb notes that if upcoming JWST observations, due any day, also show too little gas to explain the anomalous acceleration, then we may have to consider non-natural interpretations. Now, let's examine the new 3I Atlas image shared by the China National Space Administration. This was captured in early October 2025, when 3I Atlas passed about 30 million kilometers from Tianwen-1 near Mars. That might sound distant, but in space terms it's remarkably close, making this one of the closest spacecraft observations of an interstellar comet to date.
The image is fascinating: a visible tail, a bright nucleus, and a surrounding coma. The twist? From the data, scientists estimate 3I Atlas is only about 5.6 kilometers across and relatively dim. Even near the Sun, it showed surprisingly weak surface activity, far below what's typical for comets. That supports earlier claims that 3I Atlas's surface doesn't behave like a normal nucleus. It may have a skin or structure that suppresses typical outgassing.
Then JWST added yet more intrigue. According to the latest brief, Webb's instruments spotted unexpected surface traits. Using an infrared spectrograph, we were able to constrain the surface composition. The report says 3I Atlas's surface is unlike a standard comet. Researchers infer a thick outer crust, roughly 50 to 65 feet deep. And here's the kicker: that outer layer differs sharply from the interior. In other words, the outside and inside don't match. The crust's chemistry doesn't look modified by ordinary heating or space weathering. So how did it form? Was it natural, or could something unusual, even artificial, be involved?
To explain the mismatch, several teams suggest 3I/Atlas has wandered the galaxy for billions of years. With a mass near 33 billion tons, it would have been bathed in cosmic radiation for eons. Over that time, volatile ices like carbon monoxide could have been transformed into more stable species, such as carbon dioxide, potentially explaining the surface-interior contrast. The irradiated shell no longer resembles the pristine material from its birth system. That would mean the gases seen near the Sun came from this altered outer layer. But the plot thickens. Some researchers propose a bolder reading. 3I/Atlas might not be natural, and the transformed surface could be a clue. Why? The outer layer's chemistry has been likened to an industrial coating, something we associate with technology, not geology. The stark difference between crust and core lends weight to that. Previously reported detections of nickel and cyanide products could arise from processes involving nickel tetracarbonyl, a compound typically produced in industrial settings on Earth. Bottom line, two major possibilities are on the table. Either the surface was reshaped by natural cosmic processing over immense timescales, or something unusual, perhaps non-natural, happened to this body.
Many now suspect the peculiar surface is central to 3I Atlas's strange behavior near the Sun. Yet one core mystery remains. If it lacks a tail or massive gas cloud like ordinary comets, what caused the sudden bright flare and the anomalous acceleration during solar flyby? This isn't the first time 3I Atlas has baffled the field. We've seen other anomalies: its razor-precise path through the inner system, and its near passes by multiple planets, while neatly missing Earth. Stack it all together: the odd glow, non-gravitational nudge, and unusual surface chemistry, and it's no surprise scientists are more suspicious and intrigued than ever. And the silence from NASA regarding the rumored high-resolution Mars Reconnaissance Orbiter image of 3I Atlas only adds to the curiosity. The lack of a release has people asking what's really happening. After all these strange clues, what do you think 3I Atlas is? A peculiar comet from another star, or something entirely different? Tell us in the comments. That's it for today. Have an awesome day, and thanks for watching.